Hi, welcome to part 5, I think, of the text model refactor. So, since the last video, we've completed the initializer work. So all the initializers are in now, and they're all hooked in together. In theory, they're populating the helpers using the common repository. And the helper chain is kind of ready to be hooked in. However, when we did try to hook it in, we then started seeing a lot of diffs. So it seems as if something is not quite right, and that's the point of this video. Try to understand why it is that we're failing. As you can see, we just did a quick hack here, just to slot in the chain into the assistant as a way to prove or disprove whether the changes that we've made so far are actually working. Let's make sure we're recording. We are. Everything's fine. So what we're going to try to do is try to understand why it is that we're getting diffs. We should have some... let's have a look at the chain. Yeah, we do have a little bit of logging here in the chain, so perhaps we could create a code generator. Just have a look. So it seems like the orchestration model is generating diffs. So what we'll do is we'll just create a new code generator using this change, and we'll enable logging. And then we will just do a generate dogen.orchestration.dia. Now this is clearly going to break a lot of things, but not too many, so I just wanted to break a few things. Oh, actually, interestingly enough, that is actually puzzling. I was expecting to see issues here. Let's make sure the orchestration model has sufficient stuff in it. Yeah, perhaps we just don't have enough classes here in the orchestration model. I thought at least the context would kick it in. It's peculiar, actually. So if we have a quick look at the tests again, let's just make sure we see which models are breaking. We just choose one of them. I thought orchestration was one of them, but must have misread the output. Here we are. So, sorry, I confused myself. These are the orchestration tests. Now the model that's actually broken is the variability model. Okay, so let's try again, and let's just do the variability model. Now we expect a lot more diffs this time around. Okay, so just a few diffs, not too many, but just sufficient. Now what we can see here is that we seem to have lost the helper for shared pointer. However, right, as you can see here, what seems to have happened is the order in which we are running the helpers has changed. Now, it is tempting to just regenerate with this new order, but I'd like to know when these things happen, because we try very hard to make things stable sorted, just to avoid noise. And whenever we start seeing things like this where things move, it could be that we just, well, it could be that we change the order in which things are populated, which is fine if we understand why. But it could also be that we created something that is not stable sorted, and it will cause things to move fairly randomly. So let's try to understand why things would have moved. We tried very carefully to register things in exactly the same order by copying the registrars and the initializers from the existing model. So that shouldn't have caused it move. That is puzzling, actually. Why would it move? let's have a look at the chain again. And let's just diff very carefully the code in the chain. I mean, it could be, for example, that we have somewhere an unordered map. We try to avoid those things for this kind of situation where there's order is important. But it could be so we are iterating through the helper properties in exactly the same order as we were before. Key thing here seems to be that we're supplying an element ID, whereas we're now relying on the element itself. In fact, it would be interesting to know what we do with this element ID. Not that it matters really. All we're going to be doing is doing a lookup in the model for the element, so I don't think that's a big problem. In fact, to be honest, I don't think we even bother doing a lookup. We just output the element ID here, but then we just proceed to use the element, so that's no different. We are using exactly the same properties, so if that drives the order, then there should not be a difference. But we are then looping through the helper container, so that I think could be important. Okay, so let's very carefully look at get helpers. So we go to the registrar. They'll ask me to go quiet for a second, but I'm not being very silent. Right, so what we're saying that we go to the registrar. We obtain helpers by family. Right, okay, so the key thing really here is how exactly do we obtain a helpers by family? Because as you can imagine... No, but having said that, that shouldn't really make a difference, should it? Because as long as we're querying this container by the same order, it's very peculiar actually. Let's just look at this very carefully then. So we go through the helper properties. Now we know for certain that we're using exactly the same helper properties we were before, so there's absolutely no reason why that could be different. Then we loop through the helpers. Now this is the very first thing where probably we could have a problem. If the helpers in this container are not in the same order, which then makes us wonder, how are these helpers stored in this container? Which then takes us to the registrar. And so if we have a quick look at what the registrar does, remember that we have not changed in any way the helper, so we're using exactly the same helper. So and then we do a pushback. But what is interesting here is that we are creating a physical meta ID. This does not look good at all. This looks very much like we are using an unordered map here. Right, so now let's just look at this very carefully. Why was this not a problem before? So what did the repository previously do? The repository previously said, yeah, and again, so we have an unordered map, so that's fine, but then notice that this is a stood list. Right, so basically what we're saying at the moment is, given a family, one of these things is the family, the other one is the physical meta ID, and then once we obtain the physical meta ID, we have a list, and that list is then the set of helpers that we're going to go through. So no, actually that doesn't look too bad. So now let's just see what we did before. Let's just sorry, I'm just confusing myself here. So this registrar, what we really care about is the repository, if I'm honest. The repository uses all generated codes, and because we're not we are not using the formatter or the Clang formats yet, the code looks pretty hard to read. But as you can see here, we have a string here, and then we have a meta ID. So that's the family. Then the meta ID will tell you with the element type, and then finally you have a list. So that looks fine to me, because I don't particularly care about these two things. They're just used for lookups. Once I get there, I get the list, and I just look through the list. So that is not a problem. The key thing is, as long as I get into that list in the same order, everyone's happy. So the question then is, what is the order in which things are being pushed into that list? And that then takes us to the initializers. So now we have to just understand, is there any reason why the initializers will be initializing in a different order? And to answer that question, we need to understand, now there shouldn't be any reason for that, but we were very careful in copying things. However, we could have made a mistake. So first thing we have to check is, do we do the facets in the same order? I think the answer will be yes, but let's double check. So at the top level we just call the initializers for the backends, which is fine. Then we enter a backend, and here I expect to see the order is completely different. Now that's peculiar, given that we copied and pasted the code from here. I have no idea why that would be. Okay, I think we may have. Oh, I think we may have not copied and pasted the second part. Just out of curiosity. Right, first let's just resume things the way they were. So we don't want this or this or this. That's fine. So I think I suspect basically what we've done is we were not entirely as careful as I thought we were when we copied across the initializers. Now, of course, you could probably argue, I mean, why not just regenerate the whole thing, and you know. But what we tried to do in Dogen is we tried very carefully to reduce the amount of spurious diffs. The reason why we do that is just purely because it makes our life easier. Even if sometimes we have to do crazy things like this, where we're keeping the order exactly as it was before, it just takes away the need to know for sure that there isn't something important in the middle of a diff. This we learn from experience, of course. Sometimes you look at a diff and it looks very innocent, and you think, well, that's fine, nothing special. Let's just take that diff. But if you have hundred of lines diff, it's very easy to have a tiny little change in the middle of that diff and not notice that little change, and then that little change could then cause untold amounts of pain. So unless there's a really good reason for a diff, try our best not to have diffs. And here you can see clearly that was just basically the order in which we were initializing things. So what we'll do is we will do two commits here. We will first say text initialize, ensure initialization order matches TPP model. Okay, that solves one of our problems. Here we just basically should say text assorted fixes to the helper chain. And now assistant, we should say something like are just cosmetic changes, to be honest. So we'll just say something like use helper chain in assistant. So it's just a hacky version. In here we can just have something like models cosmetic changes to text model. Right, so now that solved our little tiny problem we had there. Now we're going to do exactly the same thing in assisted C#. You may think that we're going extremely slowly here, but the main reason why is because every time we have a break, such as the break you saw a second ago, those breaks are really painful. And so just to avoid having to spend hours on end debugging through these breaks, we tend to do this sort of excruciating step-by-step approach where we change something, we validate that doesn't break anything, then we just do it in whichever way, the quickest possible way just to validate. So okay, now okay, that is already the first problem. Some hackery here. You see that these functions are very similar but not identical, and the differences are probably going to come back to bite us. Sadly, there's not much you can do. So let's just and interestingly enough, we then have all this nonsense about creating a region for the helpers. Okay, well, this is exactly the sort of thing one would expect. So we now have to go to the chain and do some technical space specific code. So for anything else, I'm just going to dump the code that replaces these guys here. And then let's look at the differences here. Make sure we're not being talked to. Well, to be honest, what we're going to do actually is the following. First, we're just going to break. There's nothing wrong with that. We can just run the code. So this is definitely going to fail because, well, we're not doing the special handling that is needed for C++, for C#, should I say. Seem to have stirred too many there. Right, so with this we expect to see some diffs and the C# models. Those diffs are going to definitely be related to the regions. In addition, we probably will see something to do with the default helper, whatever that means. Right, okay, so at the moment we see a whole lot of stuff to do with regions, as you can see. So let's just first address the issues with the region. So the way this was done was by, we first need to determine, so do something like requires region. And that is basically something like e.technical space, perhaps. Provenance. So we have a lot of things here. We have a codec ID, location, a model ID. We don't really have a technical space as such. Okay, let's try the model then. M dot technical space. So again, we don't really have. So we'll just assume this is correct. That there is a front, and I just do something like this: const auto OTS, and then we could say const auto C# TS, and there could be something like identification entities technical space C#, right? So something like this. So if OTS, now all of this code, as you remember, this is just helper stuff, so we don't really care about this code. We just need it to be equivalent, so we can get on with our lives. So this is not going to be the best code you've ever seen. It just needs to give us an equivalent behavior to what we had there before. So we were dumping the helper configuration. That is interesting. I think that is actually a useful thing to. Oh, we are already dumping the helper configuration. Apologies, it's already here. So somewhere around here, we need to do something like this. Not quite that. Now we need to do it twice. So, so what we're trying to say is something like this: if you do not have helpers, well, now we do, and output the region helpers. Notice that we somehow decided that this is the right indentation, but we don't particularly care. We'll just copy and paste, so that's fine. And so if requires region and it doesn't have helpers just yet, do this. And then if we could at the end, and the end is the very end, we could say there's something similar. So if we require region, I think we copied the bang, which we don't need. And there we are. Okay, so with a bit of luck, not sure why we bothered to set has helpers to false. But there you go. So a bit of luck, this could address most of our helper problems. Let's have a look. Ah, and there we are. So that also means that all that nonsense about the default family and all that sort of stuff doesn't really make any difference. So we don't have to bother copying any of that. So then at this point we could then say, let's just build a code generator. And regenerate everything, and this should really not cause any problems, particularly because we got no C# code anyway. So text add support for regions in helper chain when in C# technical space. Add regions in helper chain when in C# technical space. Okay, so that solves that problem. And then finally we could do something similar to that, which is please use the helper chain when we are in assistant. Right, all good. Now at this point in time we have replaced the use of helpers in assistant, which means that literally everything related to helpers has now been moved across over to it's been moved across over to the text model. So to prove that, what we're going to do is we're going to start removing. Notice that we haven't actually done the proper removal, you know, that nice tidy removal. We just done a quick hack. But what we're going to do now is to prove that we are indeed correct, and that was the case, that all the helpers have moved. Let me just double check. I'm hearing some noises from downstairs. No, everything's fine. So 25 minutes into it. So now what we're going to do is we're going to prove that we've done what we said we would do by removing helpers from the individual models. And hopefully this will then cause all sorts of code to break, which will tell us if we have missed something. And so the places to check really are going to be the repository and the registrar, I should think. And that will also enable us to remove all the helper stuff from the existing initializers. And then we can work our way backwards. So I'm going to start by deleting stuff from here, just so that it doesn't really make a lot of difference because we don't really generate code from these guys, but it just helps me visually. So there's the helpers there. Not sure if you have any references to helpers here, but don't think we do. This is never quite up to date, to be fair. And similarly in C#, well, actually we'll just do one at a time. Seems sensible. Right, so we shall start with not the helper chain, of course, but the assistants. So here's the assistants. We will just remove all of this stuff here. And get helpers. As you can see here, as usual, we are very carefully removing everything. Just so that we don't break anything. I wonder if this streaming for type is not purely a helpers thing. No, actually that's definitely not. What probably is this guy here. So I wonder if it's a bit too ambitious to do that in one go, but we'll try and see what happens. Right, streaming enabled, another one. So let's just get the assistant here. Look for helper. Add helper methods. Anywhere where there's mention of the word helper. Oh, most interesting. Requires hashing helper method. I do not remember seeing anyone calling this method. And if I'm honest, it's probably not being used anymore because otherwise it would have broken something, presumably. So we'll start by removing a lot of stuff in the system. We want to basically end up with a very trimmed down. Okay, we do need an add helper method, so I think we just went a bit crazy there. I'm just going to put this back. I don't know where that was, but here we do. No, let's fix this in the diff. Right. Right, so what happens if we try to build this? Okay, seems very unhappy. Oh, oops. So what we want to get to is a point where all the helper related stuff in the assistant is being removed. And now, bingo. you can see exactly what we wanted to see, which is cases where we thought we'd done the job, but we didn't. So we forgot, and this is exactly the purpose of this exercise. When I said we didn't think that hashing was not being used, of course it was, it's just that we never noticed. So what we'll do is we'll go back to our helper transform base class, use this guy here, somewhere around here, perhaps here. We shall let's hope, this is really hoping against hope, that this thing doesn't pull in ridiculously large amounts of things with it, because what tends to happen around here is that every time you think you're close to finding a solution to a problem, there's always going to be something that causes trouble. So if we just sure why this is still moaning. And here we just want to know the hashing. Right, there we are. So actually it has to be protected. So quick hack. And now we have the right function here. Now I think, well, to be honest, let's just try to compile. I expect lots of errors to come through. It's going to moan probably that oh, actually the error is not quite what I expected. It's moaning about attribute, that's fine. I suspect we need more things to be passed in on that member function. Right, this is going to take its time, so let's look at that member function a bit more carefully. It's a shame LSP is not helping us. Yeah, here we go. So we got to the error now. So I think we just need an element. Let's see. Not sure why LSP is not giving us. Yep, I think we had to restart Clang at some point, and that caused some issues. Not quite doing what it should be doing, so just do a direct jump here. Just make sure we are, yes, we have full LSP enabled here now. Another direct jump, and then if we just, sometimes reverting the buffer is not sufficient to get proper connection between LSP and Emacs for a given buffer. So as you can see, that now seems to work. I think we will have some more breaks, specifically on the class. I thought it was types. Well, to be honest, it probably is hash, right? Here we are, and here we want something like O, maybe? O being the object, which is an element. Right, and now we're getting a few of these errors. Let's see if we can locate them. Primitive. Well, to be honest, might as well just jump over to compilation so you can see what I'm seeing. And then all we need to do is to we just have to make sure we don't break indentation too much around here. I mean, you probably would think that the indentation is already pretty broken, but which it is really, but this is stuff that is code generated, and it's code generated at the moment with without any formatting. So okay, this is an actual right, okay, this is a bit of a bigger problem. Sorry, I misunderstood this entirely. So the problem is not so much that we are within the helpers, and the helpers are determining whether you need a hashing helper or not, but worse than that, we are outside of the helpers, and then we're saying, did we require a helper? Now this is a bit of a nightmare really. So let's just look at the implementation of this function. We definitely can't have this in the helper chain because it's not going to help, funnily enough. I think we're not quite the chain, but the helper transformer I meant. So this is not going to solve our problem, because the problem is not so much that inside of the chain of transformations for helpers, it's not there that we have a problem. It's outside of it in the plain class generation. So what we need to do is we need to think. Let's look at the implementation of this thing again. So what is this thing doing? It's going through the helper properties indeed. It's not actually it's not actually directly referring to the helper. Okay, so what we're going to do, let me call this a bit of a cop-out, but what we are going to do is not get rid of that guy. I don't think we need to get rid of that. And then if we just go back to our Git very carefully here, we need to say, oh, that's fine. That's fine too, that's fine. Now that's not so fine. So unfortunately we don't have multiple the diff is not very favorable for us, unfortunately. I think what we need to do here, not sure why we added that guy again, but if we just manually undo our change. So the reason why I think we can get away with this is because I don't think we are, I mean, although this is strictly speaking something to do with the assistant, sorry, strictly speaking it's something to do with the helpers. In practice, what this code is doing is more sort of consulting the logical model to determine if a helper is needed or not. And for the purpose of the current exercise, which is to decouple the helpers from the rest, this doesn't actually add any, well, it doesn't have any, doesn't interfere with our work at present. And given that the helpers are to be removed altogether, we probably need to address this differently. You can hear quite a lot of noise downstairs, so I'll pause for a sec. So, usual chaos in Hammock. Right, okay, so now the second thing we need to do as well is, if you remember, we didn't really want to remove add helper methods. Now the reason why is because at present we have a hack. Still here nice and downstairs. As I was saying, at present we have a hack, and the hack is to use the assistant to call the helper methods for us, to execute the chain. So what we'll do, I suspect this is fine because it seems like we didn't really delete all the stuff, so there we go. Okay, now let's just go back to all those changes that we made. They're actually not good changes, and then we can run the transform. So perhaps we'll make this a bit of a short video because I think I'm otherwise required, elsewhere required, should I say. What we'll try to do with this video is try to just do the replacement of the helpers with the helper chain. Should be pretty good if we do that. We already have 40 minutes into it. That's actually not looking too bad. So this is part of the decoupling of the helpers and the assistant. As you can see, we removed all the code in the assistant that is actually directly using the helpers. In C++, should I say. I'm actually just going to see what exactly is going on downstairs. I'll pause the video first. Right, apologies for that. Situation all restored. So where are we then? We've managed to compile, everything looks fine. Let's just compile the code generator. Right, that's really good. So we've now managed to, we don't really need that, so let's get rid of that. So let's just say here text.cpp remove helper dependencies from assistant. That's quite good, and now we just need to do something similar for the other assistants. We start off with the header file, I guess. Right, so let's just have a quick look at how we should have recording. Yeah, indeed recording. So, shall not remove helper properties itself because I suspect our method still needs it. We can remove this guy. We stay with that guy. And in here, we don't require get helpers anymore. And we can remove all of this stuff here. Okay, look, I don't think we have anything else, but we don't want the helper properties right now. Helper chain's fine, there's something else. Don't need that anymore. And yeah, that's all good. So, let's try something similar and then let's see what happens if we try to run this thing. Still having some weird LSP issues. We may have changed something in the text model. Oh, there you go. It caused everything to rebuild, sadly. Should grab more water. See if there is any communications incoming. So this was just the investigation we're doing in XML. Our commits have gone through and the build looks alright. So that's all good. And once we're done with this, what we'll do next is we will start with registrar in context. Actually, one thing we did not do is to tidy up the model. Let's just do that now. So that's the end of helpers in there. And I suspect we've already done it there. That's the repository. registrar. That looks good. Right, so hopefully this will all go through. That's good. And we can do exactly what we just did with C++. Next we will tackle context. So somewhere around here we should have a context. And, this is going to have a lot of helper transforms. So let's think about this. What is the quickest way to do this? We could just we just have to make sure that we don't do too many things in one go. Remove it from here. Okay, so that's the helper. The helper's in the header, and now, so I suspect if we just do very carefully, if we just do context, with a bit of luck, this will be very self-contained. We just want to make sure we, I mean, of course it touches every other file. There is one disadvantage of this approach, is that sadly we end up compiling a lot. Which is not ideal because these compilations take some time. If we did have Unity builds, I suspect Dogen will build extremely quickly, because if we just had one build per shared object, or static object at any rate, it probably will build in seconds, I think. But at present, our code is not very Unity build friendly, unfortunately. The reason being that we use a lot of statics for the log files. For no good reason, to be honest. I'm sure there's another way of doing that, but we just haven't done it. We could, for example, declare the log files as static members of the class, for instance. That probably will be equivalent. Let me just demonstrate what I mean while that's going. So let's take any transform. Oh, we have an error. Oh yeah, that's the expected error, the creation of the context. So let's just do that, and then we can remove the repository, and we use that for something else. So hopefully, so if I take any chain, for example, or any transform to be fair, but if I take a chain, you'll see that we defined a log file and a few strings here. Now, if you were to create a Unity build for this, then you'd have a clash, because you'd end up defining a whole lot of LG variables. However, there's nothing stopping us from creating static member variable in the class itself, and then just supplying that, initializing that on the static initialization, and then using that inside of the calls to the logger. And if we did that, that would mean that there will be no state there. Similarly, we could probably use some string views for all of these guys here. This could also be defined somewhere in the header file. So I think now we say all of this, we probably should Unity. And since we've already done the analysis, let's just put here investigate adding support for Unity builds. I tend to, whenever I have some idea, just write it down before we forget about it, and just grab a couple of related links so that when we look at it we know what it means. So I could just grab a couple of these guys here. Doesn't have to be the best links in the world, just has to be something. take us to where we want to go. Annoying when you have websites like this that doesn't actually allow you to copy and paste. But one thing we can do sometimes is just to quickly go over to EU. And we can see that EU doesn't really care about this nonsense of not allowing you to copy and paste. In fact, to be honest, I should browse more from EU because EU works quite well for a lot of stuff just to read. So I'm just going to grab a couple of links that come oh, actually the other thing we should probably do is CMake, C++ Unity, Unity builds, and yeah, so let's just grab a couple of these things here. Now you may think that I'm grabbing quite random links, and they are fairly random, but the key thing is just to give us enough context such that in a few months' time when we touch this, at least we know what we mean. Should try building. So we probably should start with now that CMake as Unity builds support. We should try building Dogen this way and see if it's faster. However, we need to first remove all of the static state we have in translation units at present. Loggers, strings with error messages, etc. These should become class states. This is really the right way to do it, to be fair. And the other thing to take into account, there is also the issue with classes, private classes should I say, defined in the CDP. We need to ensure these have unique names. So there's a couple of problems there, we just need to look at that, and we probably should say that the last 10 minutes might be an exaggeration, but let's say it's 5 minutes. Okay, you're actually clocking time in the wrong place. So this should have been something like 16:10 perhaps. We have 10 minutes faffing around, and then again something like 06 to now. And in here we probably want to say something like 16:11 until 16, and that was something like 55, I can't remember. 17:06. My short-term memory is not quite what it used to be. Right, and now we can resume the activity that we had. So this is actually a very good example of how we capture stuff here in the backlog, and probably one reason why our backlog is so massive. Because every time we have an idea, it doesn't matter how random it is, we just write it down and worry about it later. So we can say text.cpp remove helpers from context. Okay, that was good. The next thing we need to do is we need to stop registering helpers. So now I'm going to be slightly more ambitious. I think I'm going to actually just get rid of helpers from the registrar, I should think. Swallow here. And this guy can go. And this guy can go. So this is going to cause absolute havoc. So right, we can ignore that. Right, so this is validation of the helper transform. Hopefully all of this is already available in the right places. Similarly, we don't need that, and similarly, we do not need that. Okay, so sadly this is not where our story ends, because now what's going to happen is all of the initializers that reference helpers are now going to break. So what we want to do is we want to grab all the helpers very carefully. Carefully is a word you hear often around here, I'm afraid. That normally means slow, but such is life. So very carefully we're going to go through these initializers, locate the helpers. Hopefully they are nicely self-contained, so all in the right order. And we can just get rid of all of them in one go. So quite literally what we're doing is to drag things from one model to the other in an incremental fashion. Not particularly pretty, I guess, but such is the development life. Life in times of a developer, I guess. Right, there's test data is another big one with helpers. So as you can see here, not sure, I think this is the reason why we're not getting a lot of LSP at the moment. It's because all these files were already open previously when we had a crash of LSP. But let's not touch these guys. Let's type. So now finally Visual Studio, which I'm pretty sure does not have any helpers. So what do we get with this then? Hopefully we don't really have anyone else using the helpers now. Okay, so most interesting. So what is the problem here? Okay, register helper. Okay, I think we kind of thus far have been getting away with something, I think, and that something is the fact that we have a cycle in our references at the moment. I'm not quite sure how we're going to get away with this, but the problem is that we need both. We need the helpers are in one model, which is text.cpp. Yeah, this is not very nice, but this is the only way to do this for now. So the helpers are in one model, which is text.cpp. We're kind of bringing them across, but we've only brought them half across, if you see what I mean. I'm not quite sure how it worked so far, to be honest, but it kind of was. You know, I didn't really want to poke too much before it broke. And so what we've done is we explicitly added a reference from the text model over to text.cpp model. As you can imagine, this creates a cycle, which is not ideal. I don't know why this has worked so far. I think it's because I'm not really sure how it worked so far, but it did. and now it just stopped working, and so now we have to actually explicitly add a reference. We just have to remember to let's put a fix me here. Remove once helpers. Well, to be fair, I was going to say remove once helpers have been copied across, but I think we'd have exactly the same issue going forward, because the formatters, the model text transforms, will go through exactly the same process. So not a lot we can do there. We just have to go along with it. Let's see what happens then. So if I just say something like text.cpp remove helpers from repository and initialization. Right, so that does the trick for C++. Of course, as you can imagine, no rest for the wicked. We need to attack C#. So in here we have similar. Now one thing you probably noticed there, and you're probably asking yourself, why did we duplicate so much code between C# and C++? I mean, did it not appear to us at some point that this was just not the right thing to do? Why did we have, assistants and helpers and all sorts of things that are really, really almost identical between these two models? And the reason why we did duplicate that is because we used our approach of first get it to work, and then after worry about making it better. Sorry, let me just concentrate for a second. And so what that means really is that we just wanted to have enough of a proof that we'd really had two separate concerns, or that there were really commonalities between the two. And that's a general approach that we take a lot around here. We first want to, it's basically the empirical approach. We want a lot of sample points before we make a decision. Sometimes something appears that something is the same or is different, or when you're doing analysis just in abstract terms, it may appear, in fact I think we remove from context. When you're doing some abstract analysis, things may appear to be one thing, and then you may be quite happily thinking, okay, yeah, I get the nature of this object is X or is Y. And then you start to, on the back of that, you start to make a lot of assumptions, and then later on you then figure out actually that's not quite right, those assumptions were not correct. The reason why that happens is because superficial analysis sometimes is misleading. You just don't have enough sample points to reach a conclusion. So now we have exactly the same problem, I suspect. What tends to happen in work is that, well, that's it. You've made a decision, you've gone with it, and refactoring is normally at a premium, so you don't have time to refactor the world. So that's why people don't really allow you in a work scenario to code like this. They wouldn't allow you to just start copying and pasting. I mean, if you put this through in a pull request, immediately you would get people saying, oh, why do we have two classes with the same name? Why are there so many similar functions, and so on, right? You never get away with this sort of code in real work. But we did it very much on purpose here, because our point is that code generation is all about gathering the examples and gathering the samples to make a decision. So therefore, before you decide that something needs to be merged or something needs to be whatever it is that you decide, first you need to have enough sample points to make that decision, which is different from normal production software, really. So that's why you're seeing a lot of this code. Okay, so that resulted in a removal of helpers from C#, which is good. Okay, so now I guess we just have to do the thing that we've been trying for a while, which is to actually move the helpers. This has to be done in one go. We can't do a few helpers and then the rest, because the helpers rely on... in fact, no, I'm not quite right there. I think I was going to say the helpers rely on an interface, but actually we've moved the interface already. So in theory, I should think you might get away with it, I think. So if I then say, just do this sample one. Now if you remember, we have the usual copy and paste error. I'm not really going to go through the pain, as we've seen before, of trying to convince Dyer that these things are in the right namespace. We just have to grin and bear. And what we'll do instead is see if we can get the colors right. Alright, there we are. And then just put the stitch template here. And give it some contents. Right, so, well, let's see what happens. I don't think it's a problem having two of these, so we'll just have to see what happens. First is, does the code even generate? I mean, oh, it generates, okay. Then does the code even compile? Nothing particularly wrong with it, so let's just give it a go. Okay, so first problem, interestingly enough, right, this is very interesting. We seem to be, okay, I suspect what has happened is we have old versions of these guys here. So let's copy these guys across again. So there should be C++ helper. Right, so if we copy these guys again and then regenerate, let's just run. Right, so as you can see here, we now have the right versions. And okay, quite nicely. It seems like it's compiling. Nothing particularly bad should happen, I don't think. So perhaps the first step we should take is to copy the helpers across, I think. What's the most incremental thing we could do here? We could copy the helpers across one by one, or a few at a time. But we probably want to know if the copying worked or not. So what happens if I... yeah, we'll just do one facet at a time, I should think. So first we'll just basically say something like text add types helpers from text.cpp. Oh, so should I generate? So that's the first bit. Then the second bit is we just go to what am I trying to do? We just go to text source. So in here we'll have, inside of C++, of course, we'll have an initializer in types, and that guy is being pointing, as you can see here, to the model, the other model, should I say. And so what we'll do is we will just say, please use hours instead. And if that works, and it doesn't, okay. Let's try to get LSB back. So Dogen.text types transforms types. Most interesting. Let's just double check that we're not doing something really silly here. So we went to types, we created a smart pointer helper. I do not know why this is not working. Let's have a look. Smart pointer helper transform in types. Dogen text types transforms types, smart meta and so on. I suspect this is just LSP going a bit crazy. Nothing wrong there. No, there's definitely something wrong. Okay, I do not understand why there is an error, but what we'll do is, just to be on the safe side, let's just copy the path to this file. And let's put it next to it. Ah, we forgot to add the backend. Okay, let's go. Right, so if we could get access to... Right, so this should be... yeah. Not sure what's going on here at the moment. Spaces here. Normally electric deletions in Emacs sort out the issues with spaces, but oh well. Not quite sure what's going on, but we'll just include that. Right, so at this point in time, we simply added there's something interesting happening here. We seem to be registering let's look at this registrar a bit more carefully. So we are saying smart port to help it transform. We are in the same namespace, so there is no need to further qualify this. Okay, this looks perfectly reasonable. However, we seem to be trying to register something. No, that's correct actually. Dogen text transform CPP types smart pointer transform. Okay, there's a registrar. Undefined reference to vtable for Dogen. Okay, good question. Why is that failing to find the linking reference to our objects? All sorts of puzzling errors. I wonder if perhaps this is where the copying and pasting has caused problems, and that is exactly what happened. Right, so let's look at this more carefully, and I bet you there's some issue here with namespaces or something like that. And if not here, then in the template itself. Right, so this is not going to be quite as trivial as we wanted it to be, purely because of the nonsense of things that we've done in the past. Right, so in the past we unfortunately hard-coded the namespace onto the template. Now this is really not a good idea. What's happening at the moment here is that there is a variable here that tells you what the namespace is, and then we use that namespace to then populate this template to go in the right namespace. This was before, because before we used to have a very flexible stitch templates that allowed you to do all sorts of weird and wonderful things. In reality, stitch templates are only used in very, very controlled sort of circumstances, and they are really only used to create archetypes, and that's what we want them to use. So what really we should do is we should just take the namespace from whatever that stitch template is. However, that's not what we have at present, and so that's going to require us to modify all of the templates for this to work correctly. So what I'll do then is I'll just regenerate this guy. I can hear some noise again. Okay, chaos averted. Right then, so with our regeneration, this will now fall over the right namespace, and then hopefully we can regen this chap. What are we doing for time? Okay, interesting. Okay, now we have another set of problems. Right, so the next set of problems is even more interesting. Okay, right, so this is going to become a bit of a complicated exercise. Which is fine, this is exactly why we're doing this very slowly and very incrementally. But let me just explain to you why this is not so trivial. So we tried to make as little changes as possible to get these helpers to move across. One of the things we didn't really want to get involved with is all this nonsense about sorry, I think I can hear some noise still. Nope. So one of the things we didn't really want to get too tangled with was we didn't really want to get too tangled with traits and other such things. Interestingly enough, we still have an include for the assistant, including the wrong thing, and we have traits. So traits are just some nonsense that we have at present, which is just a way to define strings and so forth. Now, we don't particularly care about any of that stuff. It's all old stuff that we need to get rid of. And I don't really want to carry this across to the new world. So what I'm going to do instead is, as you can see, these templates are all kind of pretty hard-coded, I guess you could say. So we could easily supply some kind of parameter with the facet, and that would then populate the facet qualified name. And in fact, we could just supply that as part of this string here, and that would do the job. And that would solve a lot of these guys here. Owning formatters, similarly, I think we could do something similar, just supply some strings. And we could just remove the assistant. So okay, so we'll just do one. I'm not going to do all of them because, as you can imagine, this will take a while. We could do that offline. But for now, let's just do the fixes that I needed. So the first thing is we need to refer to the right guy. We don't want the assistant. We don't want traits. And the rest's okay. So this is going to give us a good bang for the buck. This is going to give us something that vaguely compiles. Not quite, but it'll be very close to compiling. Right, as you can see there. Now I expected that to have been resolved, so Dogen text transforms type CPP. Why didn't that work? So what does the header say? Dogen text transforms CPP types. That actually looks sensible enough. Is this just LSP not being up to date? Let's restart. Nope, LSP really is not happy with that, so for whatever reason doesn't seem to like. Let's just look at this in a slightly more user-friendly way. Okay, right, so it's not finding the header file, and again, we made the same mistake. We got this in the end. We forgot that we need to put the back end, or the technical space, the dominant technical space, major technical space. Right, so I'm just keen on just getting one problem out of the way, which is I want this majority of errors to go away. And I'm not sure why I'm not getting them to go away. So did you mean Dogen text transform CPP types smart pointer help transform? I thought I did. Dogen text transform. Wait up. Did we not just do this yet again wrong? Concentration is always the key around here. So we really mean that. And to be fair, if we thought for 5 seconds, we knew, because it's always backend and facet. It's just that we're not really concentrating. That's why, as you can imagine, we're going to do the other 50 odd helpers offline, because it will take us about 10% of the time that it does to do this online. Right, now then, these are the errors one would expect to see, the trait errors. Right, so in order to fix these trait errors, we need a change in the templates. What we need to do is we need, I suspect this will be an enables transform, perhaps. If we take the mustache templates, we need to supply all of these parameters as arguments. Now, because all of these guys are hard-coded to do exactly class implementation and so on, I wonder what is the easiest thing. So much traits, how many traits do we have here? Well, 1, 2, 3. So whatever the current facet is, we have that in 2 different places. Right, cool. Okay, so what we're going to do for this is, I'm probably going to have to do this offline because we already are approaching an hour and a half. So what we're going to do for this is, we are going to create some more keys in this template. Everywhere where we got these traits, I mean, the reason why I can't actually just hard code this is because there's a level of cleverness going on here that is not entirely obvious when you look at this. The fact that you're saying traits.facetQname may appear that it's actually a fixed thing. In reality, yet again, there's a degree of cleverness being applied here. Every facet that you see here in the old legacy models has a traits class. And so when you are including those traits there, it's actually relative to the facet. So what we need to do is we need to have a parameter that is facet specific, that is being supplied into the helper. Now that means that I can't actually just create a simple key here that I supply, because of course then all of the helpers would have exactly the same value for that. So instead what I need to do is I need to go to each helper and I need to add a value there that is relative to the current facet. And we just do this very quickly. I mean, as you can imagine, all this is nonsense and all this is stuff that's going to go away. So we don't want to take too long. We don't want to move the traits class to the new world because it's more crap that we don't really want in the future. So we just want to do the quickest possible hack, and the quickest possible hack really is just define a new key, slot the key in there, and then apply. In fact, to be honest, I think we could probably do that very quickly here in this video. I'll demonstrate this with one of the keys. So what I'll do is very quickly, I'll just basically say, I'll say something like, if I go to, doing a lot of jumping around here in diet, I could have bookmarks for this, but so say for example I take something like types, right, and I say traits. Now I just need to do something like MASD.cpp.types. That's the facet qualified name. And then I just need to supply that into my template. So I could say something like, oops, a lot of indentation changes there, so just bear in mind we need to move this indentation to the way it was. So I could say something like facet.qualified name, and that now becomes a key that I'm going to have to supply. And since I have this in 2 different places, I could also say it here, as you can see here. So that's 2 traits that got removed. And now I'll update the enabled facet, template, this is the enable template. Let's just double check. Yep, that's correct. So I'll just update the enable template, and for good measure, I'll have to add a key here. As you can see, there's an example of a key. I'll just add another one, and this guy will be facet.qualified_name. And that key would then be MASD.c++, which is the backend, types, which is the facet, and that is it, MASD.cpp.types. Okay, there we are. So now I'm going to regenerate. And as you can see here, we have now replaced the use of we removed the use of the facets, the from traits. And so similarly, what we'd have to do, and I guess we should redo this as we complete this video, what we have to do then is to do the same thing for these guys here. Let's not change too much in the source code. However, the names of these guys are not quite as straightforward. So what we want here is, we want archetype. Yeah, actually it may be simple enough. We could just call these guys class implementation, archetype or class implementation. So let's say we do that. Something like archetype dot class implementation. Now bear in mind this is now going to be a string, so we should quote it, and almost identically we want this to be a primitive. Right, so that's that template, and that's the enabled one, that's the mustache template. And now we just have to bear in mind that we need keys for all these chaps. Right, so it was fairly straightforward, I guess. We did not copy them to the right place. We wanted it to be next to the thing we just did a second ago. So, right, so this will be MASD.cpp.types. Now we just have to be careful. It is types actually. And then class implementation, presumably. And the primitive implementation. So this will be the name of that archetype. I think we may have done some. Here we go. It's not good. Dogen does not like lots of spaces. Right, so not quite as trivial as one would have wanted, but so hopefully now that then does the right thing. And then what happens if we try to generate? Not to generate, to compile, I guess. I suspect. Yeah, okay. I'm not quite sure what we did. We already modified the initializer, so I suspect we're using the new helper. So let's just say text copy across or move, generate types. Sorry, just 1 second. What did we commit a second ago? Generate help type helpers in text.cpp. Why did this commit actually work? I wonder. Okay, I think entirely sure when we do this commit why the world did not break. I'm not sure this is actually right. I can't quite remember how we tested this, but I don't think. In fact, let me just put that to the test. So let's just uncommit this commit, and then let's just select all of these guys, and then let's just run the tests again. I'm not quite sure how this compiled at all. I would have thought this would give me lots of errors. It is possible that we're just not referencing to this file, but we should at least be compiling it, in which case. Yeah, I'm not entirely sure how exactly this worked, but nevertheless, if it did work, it's good enough to be committed. I have no idea how that worked, but let's just go with that. So, text fixes for types, facet helpers. Fix types helper types facet helpers and hook then in. I mean, there's only one, but you get the gist of it. And then if we've done our job properly, the last thing we need to now do is to say, well, can we get rid of that guy then? And then if I could just generate. So this should give you a very good overview of well, what needs to be done a number of times. So this now means that the helpers that we are using are the helpers in the text model with all the changes that we've done, traits, etc., etc. And if that all clears, so that's all clear, then we move to first helper. That's a success with that guy. Right, so that is kind of it. So we now should say something like text.cpp remove helpers from types facet. And that is the very first helper that is being moved across to this model. So you can see there, it's being moved across, everything works fine, it's tidied up sufficiently. All the decoupling worked. So this has been extraordinarily painful. I probably wouldn't have thought this would take this long and would be this complicated, and you can imagine that the pain to come is going to be not that small, because for every template here we're going to have to tidy up the template, remember to do all the includes in the right places and so on, change the keys and so on. But I don't think I'm going to bother making a video for that, because I think it's just going to be what we've just seen there several times over. And if I'm actually very concentrated, I could probably get that done very quickly, whereas if I'm talking while doing that, it probably will take me forever. So I'll get all of those tidied up. There's nothing new there, you just saw what's going to happen for these guys, just a lot quicker. And then once that's done, then we would have achieved the moving of the helpers across all models over to the combined text model, which is part half of the way really towards our objective. So what I'll do is I will clock this out, I should think. The story is beginning to dominate the sprint, sadly. And you can imagine that, to be honest, this story should be really broken down into move helpers, I should think. Because can you just imagine how much it would take to move everything else, context and so on. So we're just going to focus on the helpers really. Well, to be fair, I mean, let's just look at the title of the story again. Move helpers, context helpers, move context helper and M2T interface to text model. Yeah, I don't think this reflects the story at all. What we've done is move helpers to, yeah, that's a lot more information. You can see 60 hours, so we're close to, in fact, to be honest, we should be clocking, so maybe 1 more minute. There we go, that's the minute that we're looking for. That's 60 hours, 20 hours to go. The helpers are probably going to be another 2 to 3 hours, I should think. So it may be a bit ambitious to think that we're going to finish the merging of the models in this sprint, because I don't think the transforms themselves are going to be much easier than the helpers. If anything, are going to be more complicated, I think. But we're going to try our very best. We might even actually have a bigger sprint than usual, just to try to see if we can get to the bottom of that, because I think that's quite important. Otherwise, we're never going to get to the end of this. So if we just do a backlog grooming, and that is the end of that. So thanks for watching.